The aim of this video is to give you a step-by-step method for finding a right tail critical region and then making a conclusion. So in this question we've got x, which is binomially distributed with 30 trials, and p is the probability of success. So our null hypothesis is that p is equal to 3/5. I'm going to use decimals actually, so 0.6. And our alternative hypothesis, so we think that the probability is actually more than 0.6. So it's this part that makes it a right tail critical region, because this time we've got the probability is greater than something. So this means it's a right tail critical region. So if we think the probability is greater than 0.6, we think the probability of success is high, then we would expect x to be big. So let's bear that in mind when we find our critical region. So before we do that, our first step is to say if h0 is true, then x would follow binomial distribution with 30 trials, and p would be 0.6. You put in that null hypothesis probability, and that might be your first mark. So if we were doing 30 trials and we wanted to really convince ourselves that the probability was more than 0.6 of having a success, if we had 30 successes out of the 30 trials, then we would be almost certain that the probability would be greater than 0.6. So because it's a right tail critical region, we're going to start off with finding out what's the probability of x equaling 30. So having 30 successes out of the 30 trials. So we're going to go on distribution, binomial, PD, because we want a specific value of x. We want probability of x being 30. The number of trials is 30. And the probability of h0 is true is 0.6. So that's actually a really, really tiny probability. It's this probability here. So next we're going to do the probability of x being greater than or equal to 29. And then we're going to do the probability of x being greater than or equal to 28, etc. And we're doing greater than or equal to, in this case, because it's a right tail critical region. So to work out the probability of x being greater than or equal to 29, we're going to do 1 minus the probability of x being less than or equal to 28. So that's going to be 1 minus, and then we'll use our calculator to find this probability here. So we'll go on distribution, binomial, cumulative. We want the probability of x being less than or equal to 28. Number of trials is 30, and the probability of success is 0.6. So if we work that out, we'll get a really, really small probability again, 0.0005%. So what we could keep on doing is we could work our way down, and then we could do probability of x being greater than or equal to 28, we could do probability of x being greater than or equal to 27, etc. But that's going to take a very long time, so that's where it becomes a bit of trial and error. Remember, what we're looking for is we're looking for the boundary between a probability of being less than 5% and a probability of being more than 5%, because we're aiming for a probability as close to 5% as possible, but not more than 5%. So let's try probability of x being greater than or equal to, I don't know, let's try 25. So we'd have to do 1 minus the probability of x being less than or equal to 24. So we'll go on binomial cumulative, change that to 24, and then we'll do 1 minus that probability. So here we'd actually get 0.6%. So we're getting closer to 5%. So let's do probability of x being greater than or equal to 24. So that would be 1 minus the probability of x being less than or equal to 23. And if you work that out, you'd get 1.7%. And then next, let's do probability of x being greater than or equal to 23, which is 1 minus the probability of x being less than or equal to 22. And that's 4.4%. So it looks like the next jump, so if we do x is greater than or equal to 22, then This probability is more than our significance level, more than 5%. It's 9.4%. So remember, what we're looking for is, as we work our way away from 30, so we've gone 29, 28, 27, 26, etc., we're looking for the first probability, which is, or the probability which is as close to 5% as possible, but not more than 5%. So that's this probability here. So our critical region is x is greater than or equal to 23. So our critical region is x is greater than or equal to 23. And that basically ensures that the probability of being in our critical region is as close to 5% as possible, but not more than 5%. So for part B, we actually saw an observation of x equals 28. So when we did our 30 trials, we recorded 28 out of the 30 were successes. So basically what we got to ask ourselves is 28 big enough to convince ourselves that the probability of success is greater than 0.6? Or if x is in the critical region, so x is greater than or equal to 23, then we will reject h0. Remember that if x is in the critical region, then we reject h0. And if we do reject h0, then we're going to say that x was big enough, because it's in our critical region, and therefore there's enough evidence to suggest that the probability of success is more than 0.6. So our conclusion is going to look like this. X equals 28 is in the critical region. So we're going to reject h0 because we're in the critical region. And we're going to say, actually, there was enough evidence to suggest that h1 was true. So we're going to say sufficient evidence to suggest that h1 is true, which is p is greater than 0.6. Basically because we had enough successes out of the 30 to convince ourselves that the probability was big.